Hello, greetings of the day, dear students. In this class, we are going to discuss about the EMF equation of three-phase alternator. By the time we complete this video, we will see what are the important terminology present in this equation and how to derive the EMF equation, and also we will see its final formula, that is RMS value ERMS per phase is given by 4.44 kD kp 5 ft volts, right, where this kd indicates the distribution factor and kp indicates the pitch factor, phi indicates the flux, f indicates the frequency, and t indicates the number of turns. So here, with respect to this equation, as you are already familiar, the alternator or synchronous generator, which is going to convert the mechanical energy into electrical energy, right? So some EMF will be induced in that. Now the magnitude of how much voltage will be induced, that we are going to derive. So here we will assume Zp indicates the number of conductors in series per phase. Zp indicates the number of conductors in series per phase, and P indicates the number of poles. Phi indicates the useful flux per pole in Webers. N indicates the speed of the rotor or rotational speed in RPM, and F indicates the frequency of the induced voltage F in H, right? Now the induced EMF will be given by d phi by dt. Now the change in flux, let it be phi, and now the dt is given by 1 by 2f. dt is given by 1 by 2f, right? Here you can observe that the flux cut by any conductor while passing from the center of one interpole gap to the center of the next is 5 Webers. And since during the movement the EMF wave completes only half of the cycle, here the time taken will be given by 1 by 2f seconds. So based on that, the average rate of cutting the flux is given by d phi by dt, which is nothing but 2f phi. The units are Webers per second. The same 2f phi you can also find out in another manner. Here I will show you. For example, if you want let n be the speed of the rotor in RPM, right? That means n revolutions per minute. So per in seconds, n by 60 revolutions per second. So the time taken for one revolution will be how much? 60 by n. 60 by n. Now by the time the conductor passes through all the poles, the flux linked with that will be phi p. So here in the formula d phi by dt, okay, total number of poles are p, so p phi divided by 60 by n. But already we are familiar, the frequency f is given by the speed of the relation between the speed, frequency and poles for alternator we have seen in the previous discussions, and n equals to 120 f by p, where p indicates the poles, f indicates the frequency of the supply, and n indicates the rotation, right? So based on that, how much we will get? This is equals to the p phi n by 60. right? P phi n by 60. But what about n? 120 f by p. So this is also same as P phi by 60 into, in the place of n, 120 f by p. P cancel, 61s are 62s are. So this is simply equals to the 2 f phi. So this is also okay. In this manner also you can derive it. In this manner, d phi by dt is equals to the 2 f phi. So either the way you can find out the value of d phi by dt. In both the cases we will get 2 f phi, right? So this is the induced voltage. Now the average value, this is the induced voltage in each conductor, but the average EMF per phase, the per phase it is given by, it is to be multiplied with the number of conductors. Zp indicates the number of conductors in series per phase. So Zp times 2f phi. But already we are familiar with Z is equals to the 2t, where t indicates the number of turns, right? So here in the place of Zp we can write simply 2t. So 2t into 2f phi. So overall we will get it as 4 phi ft volts. So here one important point is this induced EMF or average value of EMF per phase is valid if the winding is of for full pitched coil or concentrated coil, it is okay. But practically what happens is if it is having some pitch factor and distribution factor, Kp and Kd values, then the same average value per phase is given by, if you have considered Kd value, then we will get it as 4 Kd phi ft. Similarly for short pitch winding, the true average value of EMF per phase will be Kp times the value, so it will be equals to the 4 Kp Kd phi ft. But one important point is all these values are average values only. All these values are average values only. But we are familiar with one relation, form factor. Form factor is given by form factor is equals to what? RMS value by average value. RMS value by average value. So obviously if you want RMS value, if you want VRMS, it is simply the form factor. For sinusoidal waveform, the form factor value is 1.11. Form factor times the average value VAVG. So now the RMS value per phase is given by form factor times average value. Here the form factor we can denote with the letter KF. So here KF, KD, KP times phi ft, where KF indicates for sinusoidal waveform, especially if it is for sinusoidal waveform, the form factor is given by 1.11. So finally the RMS value per phase is given by RMS per phase is given by 4.44 KD KP phi ft, where KD indicates the, what does the KD indicates? KD indicates the distribution factor. Kp is the pitch factor. Kd distribution factor. Kd is the distribution factor, and phi flux. Phi is the flux. F is the frequency of supply. F is the frequency. Frequency. FREQUENCY frequency, and T indicates the number of turns. So this is the final equation. right? So I repeat again, if it is for full pitched or concentrated windings, this Kp and Kd value will be equal to 1. Kp equals to 1, Kd equals to 1. When if the winding is of full pitched winding or a concentrated winding, then the values will be equal to the 1, right? So this is what about the EMF equation of three-phase alternator. In this entire discussion, the key point is d phi by dt is equals to the 2f phi. Either you can derive like this or we already know that n indicates the speed in RPM. So if you express in seconds, n by 60 revolutions per second, the time taken for one revolution is 60 by n. Now d phi value is equals to the p phi, where p indicates the number of poles, right? And dt value indicates the 60 by n. So it is simply p phi n by 60, and we are already familiar with n equals to speed 120 f by p. Based on that, you can substitute the value of n, and finally we will get d phi by dt, change in flux, rate of change of flux, which will be equals to the induced EMF will be equals to the 2f phi. So that is simply the average value, but slowly we will focus that is only for each conductor, but we want for total conductors and per phase, and finally we will find out the RMS value. And another important point is RMS value. Now form factor equals to RMS value by average value. Once if you want the RMS value, form factor into the average value. For sinusoidal waveform, the form factor value is 1.11. So because of that, we will get 4.44 kd kp phi ft volts. That is the RMS value of the induced voltage per phase, right? Thank you.